Deep inside a high-security facility in China, something extraordinary is happening. They're not building ordinary machines. They're building humanoids, robots that can see, move, learn, even think. From molten metal to artificial muscles, from silicon chips to synthetic skin, every step is controlled, every detail classified. This is how an AI-powered humanoid comes to life: the brain. The process doesn't start with a body, it starts with a mind. Inside a restricted clean room, the robot's brain is born. Advanced AI processors. Edge GPUs. Control units are stacked in layers. This system will handle perception, motion planning, real-time decisions. There's zero room for delay. A single millisecond of lag could mean failure. Engineers flash custom firmware. Tune motion algorithms. Profile every microsecond. Hardware and intelligence must work as one. Once complete, the computing core is sealed inside reinforced metal housing. This step requires absolute precision. One misalignment, the robot can't think, can't react, can't learn. Only highly trained technicians are allowed inside. The mind is complete. Now the body begins. Raw materials. Deep inside the manufacturing complex, sealed containers arrive under armed guard. Aerospace-grade alloys, carbon fiber composites. Each batch is scanned. Verified. Laser etched with unique codes, every gram is tracked. Nothing leaves the system unaccounted for. This isn't just quality control, it's total accountability. Forging the skeleton. The materials move into the precision fabrication zone. Raw metal is loaded into furnaces. Temperatures hit 1,450 degrees Celsius. Solid ingots turn to glowing liquid. The molten metal is forged into foundational components. Then it enters CNC machining cells. These machines carve torso frames, limb structures, joy housings. Tolerances measured in microns. Die casting lines produce complex shapes. Robotic welding systems fuse the core frame. No human hand touches the weld. Every component undergoes deburring, surface polishing, anti-corrosion treatment. This ensures durability, smooth articulation, environmental resistance. The skeleton is taking shape. Mechanical assembly. Now comes the most critical stage: harmonic reducers, high-torque servo motors, linear actuators, torque sensors. Each joint is a symphony of precision parts: bearings, gear trains, dampers, backlash compensators. Stacked in exact sequences to replicate human movement. Every joint is calibrated individually. Power, flexibility, responsiveness. All three must balance perfectly. The central vertebral column is installed, then the sternum, the rib cage. The internal frame is complete. But metal alone can't move like a human. Artificial muscles. In a separate laboratory, something unusual is being prepared. Artificial muscles. Created from specialized chemical compounds engineered to contract and relax under load. Once prepared, each muscle group is transferred to the assembly floor. Technicians attach them to the skeletal frame. The robot now has strength, elasticity, natural motion dynamics. It's no longer just metal, it's starting to feel alive. The nervous system. Movement requires control. Technicians route complex wiring through internal channels, power buses, thermal management systems to regulate heat during intense work. Hand movements are designed using electronic stimulators. Engineers fine-tune finger articulation, grip precision. Inside the head, a dense network connects the brain to the body. Eye muscles are installed, linked to the vision system. The robot can now move its eyes. Focus, track movement, power and first activation. In parallel, battery packs are being built. Individual cells are graded for performance. Battery management systems programmed. Safety isolation checks prevent overheating or electrical failure. These power units must deliver stable energy under extreme conditions. The battery is installed. Now comes the moment of truth. Engineers run diagnostics, hand movement tests, leg movement tests. Hydraulic systems checked, pressure tested, thermal management evaluated, motors spin, joints flex. Internal temperatures are monitored in real time. The robot receives its feet. A controlled walking test begins. Balance, stability, gait symmetry. Engineers analyze every step, adjust motion parameters. The robot is walking. Touch. But it can't feel anything yet. Synthetic skin is prepared using advanced chemical processes. Flexible, lifelike, embedded with dense pressure sensor grids. Engineers apply tactile skin across hands, feet, and body panels. The robot can now detect touch, grip force, environmental feedback with remarkable precision. Sight. Next comes vision. Stereo cameras, depth sensors, LiDAR units, mounted and aligned with extreme accuracy. The humanoid now has spatial awareness, depth perception. It can map surroundings, recognize obstacles, understand three-dimensional space. The robot can see. Cosmetic finishing. The robot moves into clean room cosmetic finishing. Exterior shells fitted, synthetic skin bonded seamlessly. Facial actuators installed for realistic expressions and speech movement. External features complete the final appearance. It looks human, but can it act human? The real test. The robot is transferred to the final testing zone. Now the real challenge begins. Inclined movements, declined movements, stairs, dust, gravel, sand, metal sheets, stone. Styrofoam. Each surface test balances traction and adaptability. Then, the collision tests. Engineers deliberately push the robot, destabilize it. It must regain balance without falling. Next, the endurance run. Nearly 1 hour of continuous movement. Testing mechanical reliability, heat control. The robot doesn't stop. Fine motor skills. Now for precision. Pick up an egg without breaking it. Stack coins. Write names. Draw a perfect circle. There is a need. Each task pushes the limits of what a robot can do. Environmental stress. The robot enters a chamber. Temperatures drop to extreme lows, then rapidly rise. Thermal endurance tested. Then water submersion. Testing functionality in wet conditions. Impact testing follows. Heavy rods strike the robot. Measuring structural integrity. Intelligence. Communication systems tested. Speech, hearing, language processing. Object manipulation drills continue. Grip strength, coordination. Finally, real-world tasks. Opening doors, sitting in chairs, dancing. These aren't just mechanical movements, they're learned behaviors. Intelligence in action. Deployment. Finished humanoids secured in custom foam cradles, sealed inside export-grade crates, ready for shipment. These robots will enter research labs, industrial facilities, public environments. From raw metal to thinking machine, the process is complete. From molten metal to artificial mind, this is how China builds the future, and they're just getting started. If you want to see more inside these secretive factories, hit subscribe, because what comes next is even more unbelievable.